Well, hello everybody. This is Sebastian64 speaking from Sicily as I'm on vacation, but this is something I really wanted to show you because it's very, very special. It's in regards to the MP2 GDI project, which, for those who are unfamiliar, is a project started by me, NeoZed, and RoyTam1 in an effort to get Neko Project 2 ported to as many versions of Windows NT as possible, and that includes all the RISC architectures. And one of those that I want to feature today is the final one from the early 2000s that we wanted to try it out, which is Itanium. And not just any Itanium, first generation Itanium for the Merced architecture. These were featured on the Intel SDV, so-called SDV machines, which were workstations from around the year 2000, maybe even 2001. Meant to onboard developers onto the Itanium platform, and also to get Windows to be ported, to be adopted as like a 64-bit operating system before we all switched to the MD64, of course. This is different from the Itanium 2 series of chips, which are the McKinley architecture and onwards, which have higher clock speeds and everything. So this is basically the first generation. It has, for the time, pretty miserable clock speeds, and comes with an on-chip x86 translation layer, which was apparently so bad that it was gutted, and operating systems like Server 2003 and onwards didn't even use it anymore and used the software translation layer. So we used the platform SDK to build a version of Neko Project 2 that's specifically tailored for Merced chips, and I'm going to demonstrate to you exactly how it works today. Of course, as you might see on the right side, this machine is graciously provided remotely by Antoni Savitsky, also known as Tenox7 online. Much appreciated, thank you very much, Tenox. Otherwise this demonstration or even testing would not be possible. Now, I am running this on like the stock MP2 settings of 10 MHz, a 286 system emulated, so it shouldn't be too demanding, but observe the CPU usage here. Just keep an eye on that. This is the intro sequence. We don't have any audio because the audio service has been disabled, so that's just how it is. And just as a reminder, this is a native Itanium build for the 64-bit, a 64-bit program. HDP isn't exactly doing favors for screen refreshes, but we can move. It's not that bad. We can kind of sort of play the game. It's just gonna laggy. Alright, we got the first key. Oop, I bumped into a wall. So, not the worst thing in the world, but still pretty underwhelming, all things considered. There's our first encounter with a will-o-wisp. Gonna use a ice storm on it. Yeah, just usual Banda Monogatari gameplay, nothing special here. Now, I also made a build with the leaked Razzle build system for Windows Server 2003 post-RTM, and believe it or not, that one also actually works pretty well. Actually, you know what, I'm not going to demonstrate it because you're pretty much going to get the same exact gameplay as before. But yeah, the special thing is I did tell the compiler to optimize for Merced and a special build for McKinley, but the output executables were byte for byte identical. Not exactly sure what's going on there, but yes, you can use the later compilers to build for first gen Itanium and it will work. Now this right here is actually built for an earlier compiler. This one was actually targeting NT4 with, I believe, VC6. I believe VC6 uses 9.0 OCO. And yeah, this is a 32-bit x86 program running on Itanium. This should use the software translation layer, I believe, but don't quote me on that, considering this is Server 2003 we're running on. And already, even though it says the CPU usage isn't that high, we're not exactly seeing the greatest of performance. It's just on drawing text. As you can see, it takes a while for the intro to draw. And for the eyes to blink. Trust me, it gets so much worse once we actually get into the game. Again, slow, the screen draws, not exactly unusual with RDP, but these aren't RDP blocks we're seeing. These are lines coming from the emulator itself. And oh god, it's still drawing the final update. Alright, I think we're good to go now. As you can see, the blinking animation is just... oh god, you know what? I can't even move. Oh, there it is. It's just about managing to draw the screen, but I really gotta hold the direction I want to go in for anything to actually happen. As you can see, the emulated CPU speed dropped to below 1 megahertz. This is literally slower than a Commodore 64. And I can't move. I generally can't move. It takes so... oh, there it is. It takes so long for the emulator to register my inputs that the game... that it's just unplayable. That's how bad x86 code runs on Itanium. Oh, there's an encounter. And yeah, Intel genuinely thought they could replace x86 with this and have people actually run existing software. Like, this is horrible. Like, oh god, if this is actually using the on-chip translation layer instead of Microsoft software translation, god, like, this is genuinely worse than on a 486. Yeah, I think we're done here for now. But so yeah, this was really just a test to see if we could get a native Itanium build to work, and to see just how much worse running x86 with software emulation is. And wow, it's horrible. So yeah, many thanks to Antoni Savitsky for providing us this machine to test on. And hopefully we might see each other again on another strange RISC platform. If I get my hands on an Alpha 64 again, maybe do more than just a screenshot.